time we're going to continue with our multiple representations in the form of slope-intercept form. We're going to look at our equation that we have. So we have y, our output, equals our beginning amount, 12, plus 1.5 times x. And we can look here, and we're talking about Joey's Pizza Parlor cost, the number of toppings down here on our x, and then our cost of the large pizza. So this is x is the independent, so that means that the cost of the large pizza is the dependent y variable, depends on the number of toppings. Okay, so a description looks like we're going to talking about number of toppings, and y is 12, so we can tell just by looking at this graph that the cost of our large pizza is $12, just looking at the graph, our y-intercept here. So we could say that as a verbal description, a large pizza costs $12, and then we can add plus $1.50 for each. And I would put additional A, B, D, apostrophe L topping. So maybe it comes with one topping, maybe even two before then. Okay? So we can see that if we had 0 toppings, we'll just assume that's cheese. Okay, we've got cheese there. We have the cost of the pizza, it's $12. So we had $12, and then we added $1.50 times 0, that's our x topping, so our cost is 0. Our coordinate then, x is 0 and y is 12, that's our y-intercept. So again, remember, whenever our x value is 0, this is going to give us our y-intercept. It's our beginning amount, our starting, okay? So we know then, okay, so if we had 1 topping, then $12 plus $1.50 times 1, which is going to give us $13.50. $13.50 for our large topping. We had 2, it would be 12 plus 2 times, my bad, this won't see you. Plus $1.50 times 2. $1.50 times 2 is 3, plus 12 is 15. Okay, so 3, we have 12 plus $1.50 times 3, that's $4.50 plus 12 is going to give us $16.50. 4 toppings, 12 plus $1.50 times 4, $1.50 times 4 is 3. But 1, 2, 3, 4, 5, 6, 6 plus 12 is going to give us $18. And 12 plus $1.50 times 5, that's $7.50 plus 12 is $19.50. And 6 toppings would be a great pizza. And 5/10 times 6 is going to give us 6 plus 12 is $21. And okay, so let's go ahead and plot those points as I answer this little work. Okay, so with 0 toppings, you can see right here with 0 toppings, we've got a y-intercept. These half points I'm not going to worry about. Okay, so let's go with 2 toppings, and then we've got $15. Okay, so with 2 toppings, and we're going up to between 14 and 16, about right there. Okay, and for 4 toppings, 18. All the way up here, that's a good point. And for 6 toppings, 21. Looks like we busted about there. Okay, so let's go ahead and get our graph and graphing in here. Okay, got that. Put it on hold if you need to, please. And so let's look at the next one. Okay, so on this one, you can see that we have a table, and that's about it. Okay, so we can look and see we've got Woodbury Watermelon Patch, that's the title. And our independent variable is the number of watermelons. Looks like we're skip counting by fives. And the weight in pounds, okay, and we're skip counting by threes. Okay, so we're going to have to look back and see what our y-intercept is. So you can see that we're skip counting by fives all the way back. We can go back 5 more. That's going to give us 0. We're skip counting by 6s, 6, and so 0. Looks like then the number of watermelons at 0, we have 0 pounds. We've got a proportional relationship. We started at our first coordinate, 0, 0. Okay, so our process then, I'm going to write the equation. And so our y-intercept equals our slope, m, plus our r times x. Y-intercept is 0. So we don't need that. I'm erasing it. Okay, so we can say that y, and so now we're going to have to put the change in y over change in x, or y2 take away y1 over x2 take away x1. Okay, so we're going to take our coordinates. I'm going to call this, these are our x's, there's our y's, and so I'll call this y2, y1, x2, x1. Okay, so here we go, 12, take away 6, there's our y's, 10, take away 5, and give us 6 over 5, that's our slope. Okay, we're going to do rise over run, and we have to be careful about it on our skip count. Okay, so here is our slope. Our process is going to be 6/5 times 5, and let's see if that gives us 6. Let's see, cross reduce, it does. Okay, so 6/5 times 10, and the way that I would be figuring this in is I would say this 10 goes on top, 10 and 5 can both be reduced by 5, that would give us 1, 2, 6 times 2, gives us 12. That's correct. So let's just keep going. So we should say 6/5 times 15, should give us 18, 6/5 times 20, you can put this in your calculator if you need a different way to calculate, times 25. Okay, so let's go ahead and plot our points. Here's our x, there's our y. So 5 and 6, there's 1 point. X 10, y 12. 10 and 12. 15, 18. 15, 18. 20, 24. 20, 24. 25, 30. And 25, 30. Okay, so there are our points. All right, Emma?
Yeah. Hi.
Okay. So that is it. Summarize today's lesson. So we should be able to use multiple representations. No, let me draw your vertical line just right there. Let's see if it passes through more than one point. Okay, so today's lesson, we were able to use multiple representations to represent a linear equation in the form of y equals m times x plus b. Go out and bless others. It's just like